Assalamu alaikum. The topic of today's discussion is source of light in a spectrophotometer. In the previous discussions, we have studied in detail different parts of spectrophotometers, whether it is single beam or double beam spectrophotometer, and briefly we have also discussed the sources of light in single beam or double beam spectrophotometer. So in this lecture we will study in detail sources of light either in the visible region or in the UV region or in the IR region. So first we will discuss the source of light in the visible region. The source should have a readily detectable output of radiation over the wavelength region for which the instrument is designed to operate, but no source however has a constant spectral output. So for visible region, the most commonly used source of is a quartz tungsten halogen lamp. So for the operation of quartz tungsten halogen lamp, it also needs a constant power supply. For the power supply, LEDs are the most efficient ones. This graph is showing the wavelength range supplied by quartz tungsten halogen lamp. So for the emission of radiation from quartz tungsten halogen lamp, LEDs are used as a power supply, and LEDs are very efficient power supply, and they can be operated as low as 6 volt. So in this graph, as you can see, that relative intensity of radiation, it is plotted against y-axis, and wavelength is given against x-axis. A relative intensity has an arbitrary value up to 1. So we can see that intensity of radiation as a function of wavelength for two typical light source, quartz tungsten halogen lamp, and it is operating at 3300 Kelvin, and it exhibits useful light intensity from 350 to 2500 nanometer. So as you can see from the graph, that intensity of quartz tungsten halogen lamp, that is quartz tungsten halogen lamp start emitting radiation from 350 nanometer and it extends to 2500 nanometer. So we can perform analysis with quartz tungsten halogen lamp from 350 to 2500 nanometer. Here in this graph, the spectra of a white LED is also given, and a white LED actually it consists of a blue indium gallium nitrogen material, and it emits at 450 nanometer. It start emitting radiation at 450 nanometer, and then it has a peak value right after that, and then the value intensity of radiation then drops down. Actually this LED, this is also coated with a broadband phosphor that has a peak emission in the green at 550 nanometer. That this LED, it is made up of the material indium gallium nitrogen, and then this is coated with broadband phosphor, and because of this broadband phosphor, it will has a peak emission in the green at 550 nanometer. So white LEDs, they can be used as a itself as a source in the visible region for analytical purposes, and also it will act as a power supply for quartz tungsten halogen lamp in the visible. Next we have sources of light in the ultraviolet region. For the ultraviolet region, a low pressure deuterium discharge lamp is generally used. So this is the source of light in the ultraviolet region, that is low pressure deuterium discharge lamp. The deuterium continuum emission extends from 185 to 370 nanometer. So you can see that that deuterium give continuum emission from 185 to 370 nanometer, that is below visible region and in the ultraviolet region. But the lamp has useful spectral output out to 600 nanometer, so it can extend to 600 nanometer. But the continuum emission is from 185 to 370 nanometer, although it can go up to 600 nanometer, but then it will not be continuous. it will be interrupted. So most preferably, that is why it can be used in the ultraviolet region, that is up to 370 nanometer, which is below visible region. Ultraviolet sources must have a quartz window. This is also one of the requirement uh, for the usage of ultraviolet source, that it must have a quartz window. That is, after emission of the radiation from the source, it should pass through a quartz window, because if the window is made up of glass, then it will absorb radiation and the intensity of the radiation will decrease, because ultraviolet radiations, these are not transparent to glass, but to quartz these are transparent. So this is also one of the requirement for the use of low pressure deuterium discharge lamp for ultraviolet region. This is the block diagram. Although we have studied in detail the components of single beam and double beam spectrophotometer, but just in order to have a short review, first we will have a source for the emission of radiation. This source must be supplied with a power supply. Then the radiation emitted will pass through monochromator. Monochromator will divide the radiation. You can say a continuum spectrum into monochromatic light. This monochromatic light then will pass through the sample. Sample will absorb some amount of the radiation and some of the amount will be emitted. The emitted radiation will be detected by a suitable detector depending upon the wavelength range which we study, and then the detector will send signals to read out device which will be displayed on computer. Now we have sources of light in the infrared region. As infrared radiations, they are essentially heat. So we can use hot wires, light bulbs, or glowing ceramics. They can be used as sources. The energy distribution from the black body source tends to peak at about 100 to 2000 nanometer, which is near infrared region, and then tails off in the mid IR. So we would use a black body source which will actually absorb all the radiation, and then it will absorb it will emit radiation in 100 to 2000 nanometer, which is near infrared, and then it will tails off in mid IR. Infrared spectrometers usually operate from about 2 to 1500 micrometers. So in the previous lecture we have studied about the useful analytical range of infrared spectrometry, which is 2 to 15 or 16 micrometer, and because of the relatively low intensity radiation in this region, relatively large slits are used to increase the light throughput. So in this region actually the intensity of radiation is low, so we have to use large slits so that the large amount of radiations can be allowed to reach the sample. But the problem with this is that this will degrade the wavelength resolution. So in order to overcome this problem, that is wavelength resolution, an interferometer is preferred, and by means of interferometer we can overcome with the problem of wavelength resolution. So this is all about today's lecture. So if you have any problem, please mention in the comments, and we will meet soon with the next lecture. Allah Hafiz.